The summer of 1936. The Dust Bowls are burying the Midwest. The construction world is running on steam, muscle, and brute force. But in a dirt floor shop in Iowa, a small group of mechanics was about to pick a fight with the industrial giants of Chicago. Armed with nothing but sheet steel and a math problem, they began building a monster that didn't just move Earth, it changed the concept of speed itself. We call it the link belt LS-98, the Corvette of the job site. It was a friction-driven outlaw that demanded a piano player's touch and punished incompetence with lethal force. And while the rest of the world surrendered to the safety of the microchip, this 60-year-old survivor remains the apex predator in the frozen hell of the Alaskan North slope. The question is, what does this ancient outlaw know that modern engineering forgot? Back in the 30s, the construction world didn't run on computer chips. It ran on brute force. If you wanted to move Earth, you sat in a steel box and wrestled a machine that fought you for every yard. The old-timers were called piano players, not because the work was pretty, but because they were ripping at 4 or 5 heavy levers constantly. Thousands of pulls a shift. 8 hours of work that didn't just make you tired, it left your hands clawed and your back shot. Two very different companies were about to collide and fix that. In Chicago, you had Link Belt. These guys were heavy industrial royalty. William Dana Ewart founded the company on one simple rule. He hated downtime. He designed a drive chain you could fix in a muddy field with nothing but a hammer. That hammer-friendly philosophy was the backbone of the company. They built gear that was heavy, durable, and slow. But the 1930s brought the New Deal and road money. Contractors needed velocity, and Link Belt's big industrial cranes were too fat to chase the asphalt crews. Enter the second player, Speeder Machinery, out in Cedar Rapids, Iowa. If Link Belt was the heavyweight boxer, Speeder was the sprinter. They started as a dirt floor operation without massive foundries to cast giant iron. Founded by George T. Ronk in 1919, Speeder wasn't interested in the status quo. Ronk was a guy who looked at the slow, steam-powered world and saw a math problem. He didn't have the capital to build heavy cast-iron bases, so he bet everything on welded fabrication and electric welding. Technologies that the big Chicago firms considered risky at the time. He was building the future out of sheet steel, while the competition was still pouring iron. In 22, they dropped the Tumblebug, the world's first wheel-mounted excavator. That changed the game. You could dig a culvert at dawn, tow the rig down the highway, and break ground in the next county by lunch. No clinking tracks, no lowboys. By 1939, Link Belt saw the writing on the wall. They bought Speeder and moved their entire crane operation to Iowa. It was a smart play. They took the heavy Chicago iron and mated it with Cedar Rapids mobility. Plus, they got the Iowa farm boys, mechanics who knew how to improvise and didn't cost union wages. But now they had a new problem. You had a fast, heavy machine, but you still had a human limit. In the days of friction cranes, the operator was the servo. You pulled a long steel lever mechanically linked to a clutch. To hoist a load, you had to physically engage the drum. To stop the swing, you didn't just brake, you had to plug it, reversing the lever to fight the momentum with raw engine torque. It was a brawl. Link Belt's answer in 1936 was the Speedomatic. This was radical stuff. Instead of a mechanical linkage, they used a low-pressure hydraulic system. But don't confuse this with modern excavators. The oil wasn't lifting the load, it was just throwing the lever for you. Think of it like power brakes on a truck. The system did the heavy work of engaging the friction clutch, but your hand still controlled the feel. On the job site, the reception was mixed. The old guard looked at those hydraulic lines and just saw leaks. They called it power steering for sissies and didn't trust it. But you couldn't argue with the dirt pile. Because the operator wasn't fighting the machine, he wasn't dead tired by noon. A fresher operator meant 25% more production per shift. Link Belt had found the holy grail, operator endurance. So they had the durability of the chain and the speed of the hydraulics. But there was one mechanical bottleneck left. The machine could hoist, it could swing, or it could travel, but it couldn't do all of them at once. To build the ultimate predator, Link Belt didn't just need a tweak, They needed to achieve the mechanical impossible. That redesign hit the dirt in 1954. Link-Belt dropped the LS-98, and it wasn't just a facelift. If the construction site was a highway, the LS-98 was the first true American muscle car. They kept the Speedomatic system, but they supercharged it. They added a high-pressure accumulator, basically a storage battery for hydraulic energy. That meant when you touched a lever, the response was instant. No lag, no waiting for the pump to build pressure. This gave the operator feel. Air controls were binary, on or off, jerky and loud. The 98 let you feather a clutch with microscopic precision. You could set a steel beam on a bolt pattern without scratching the paint. But the real heart of the beast was the independent gear train. On the old friction rigs, the mechanics forced you to choose. You could swing or you could travel, not both. The LS-98 killed that limitation. It used independent shafts mounted on involute splines. Instead of a single keyway taking all the stress and shearing off, the torque was spread across multiple teeth. The result? No more stop and go. A good operator could hoist the load, swing the boom, and travel the tracks all at the same time. It was a mechanical dance that let you cycle faster than the competition. To keep up with that speed, they ditched the heavy angle iron booms of the past. They rolled out the patented tetrahedral boom. Instead of a simple box, they welded 4 tubes into a diamond shape. This geometry made it incredibly stiff while shedding massive amounts of dead weight. They built it out of T1 steel. This wasn't just a standard structural beam. T1 was a quenched and tempered alloy with 3 times the yield strength of ordinary carbon steel. This allowed the engineers to use thinner walls on the tubing without sacrificing rigidity. Every pound they shaved off the boom was a pound of dead weight converted into live payload. It was the first time a crane manufacturer treated a boom like an aircraft wing instead of a bridge girder. But the genius of the 98 wasn't just in how it dug, it was in how it moved. Moving a crane used to be a 3-day nightmare of sledgehammers and disassembly. The LS-98 was designed for lowboy logistics. It featured a patented counterweight removal system that worked fast. You could strip the heavy iron off, slide it onto a trailer, and be gone while the other guys were still looking for the wrenches. That mobility defined the battlefield. You had the Bucyrus Erie. They were the Chevy truck, reliable, heavy, but slow as molasses. You had Manitowoc, the Rolls-Royce. Beautiful machines, but expensive, and a headache to transport. The Link-Belt LS-98 was the Corvette. It was affordable for the independent guy, fast enough to outwork the Bucyrus, and mobile enough to chase the money across state lines. It became the default weapon for the hungry American contractor. The 98 filled the skyline of post-war America, but success is a dangerous drug. As the sales charts climbed, the focus in Cedar Rapids shifted. The power moved from the grease-stained drawing boards of the engineers to the polished tables of the boardroom. The LS-98 had conquered the job site, but back at headquarters, the power was shifting. The engineers were about to lose control to the one group of people who didn't care about dirt: the accountants. By the mid-60s, the LS-98 owned the road and the job site. It was the undisputed king, but back in Cedar Rapids, the air was changing. In 1976, the FMC Corporation bought Link-Belt. This wasn't just a buyout, it was a culture shock. FMC was run out of San Jose by guys who looked at spreadsheets, not welds. They brought a bean counter mentality that clashed hard with the grease-stained pride of the Iowa plant. You saw it in the branding. FMC slapped their new Spark logo on the machines to modernize the look. The disconnect was so severe that when FMC introduced the logo to replace the traditional Link-Belt chain emblem, the Iowa workforce nearly revolted. They saw that abstract logo as a mark of ownership by people who had never welded a beam in their lives. To the men on the floor, the Link-Belt name meant quality. The FMC name just meant paperwork. The original culture of innovation was being suffocated by corporate branding. But the real poison was the Vietnam War. As the war escalated, the military needed equipment that was rugged and field repairable. They didn't want fancy experimental hydraulics. They wanted proven cable machines. Uncle Sam placed massive orders for Link-Belt cranes, keeping the production lines screaming at 100% capacity. On paper, it looked like a boom. In reality, it was a trap. Those guaranteed government contracts made the executives fat and lazy. It insulated them from the real market. While they were busy counting military shipments, the world was shifting beneath their feet. Over in Europe and Japan, early hydraulic excavators from Poklane and Kering were showing up. To the veteran engineers at Linkbelt, these things were a joke. They looked like ugly, leaky toys. They had no speed and no cable snap. The American leadership looked at them, laughed, and went back to building friction rigs. They convinced themselves that hydraulics were a fad for digging basements, not for serious work. They were wrong. FMC flooded the market with LS-98s, chasing volume instead of evolution. They were saturating the world with a machine that was mechanically perfect, but technologically dead walking. The industry was moving toward the brute simplicity of hydraulics, machines any rookie could run. The LS-98, for all its speed, demanded a master in the seat. And as the machines aged, people started to notice the price of that performance. If you looked inside the cab, you didn't see a workspace, you saw a cage. And inside that cage, the line between a record-breaking shift and a closed casket funeral was razor thin. To understand the true price of that speed, you have to look past the steel and focus on the two men keeping the beast alive, the operator and the oiler. It wasn't just a job, it was a hierarchy. The oiler was usually a kid, an apprentice trying to break in, and while the operator ran the show, the oiler had the miserable job of keeping the machine from melting down. The LS-98 wasn't a change-the-oil-and-go machine. It had up to 140 distinct grease fittings. It was practically a suicide mission. To grease the house rollers or the internal spider gear, the kid had to crawl right into the center of the carbody, directly underneath the spinning cab. He had to work on the main vertical gear shaft while the engine was running and the machine was swinging over his head. He was inches away from spinning gears. But up in the seat, the culture was even wilder. A high-baller mentality took over. The LS-98 was the fastest way to print money, so operators pushed the machine past the red line. They weren't just running the crane, they were hacking it. The most famous trick involved a $5 pair of Vise-Grips. Operators would clamp the pliers onto the throttle rod, physically locking the Detroit diesel at maximum RPM. It kept the engine screaming, ensuring instant horsepower for the hoist and swing. This effectively killed the deadman feature. The machine was designed to return to idle if the operator let go of the controls, a safety feature meant to stop the chaos if a man had a heart attack or got knocked out. The Vise-Grip turned a dead man switch into a live man switch. If you slumped over, the engine kept screaming and the load kept moving. That aggression highlighted the machine's darkest trait: brake fade. The LS-98 was a friction crane. You stopped the load with your leg muscle, but if you rode the brakes too hard, the asbestos linings would overheat and glaze over. The surface turned to glass. You could have an operator standing on the pedal with all his weight, veins popping in his neck, and the drum would just keep spinning. That's when you got freefall. When a load plummeted and you tried to catch it too hard, the physics turned violent. The sudden stop sent a shockwave shooting back up the wire rope. It caused birdcaging. The strands would pop open, looking like a birdcage. When a plummeting load is stopped instantly, the energy has to go somewhere. It travels as a kinetic shockwave shooting back up the line. When that wave hits the drum, it rebounds, compressing the rope strands against themselves. The wire twists open. Once a rope is caged, its structural integrity is gone. If that shock exceeded the steel's tensile strength, the rope didn't just break, it snapped like a bullwhip. And remember, the LS-98 had an open cab. A snapping cable became a steel cobra looking for a head to take off. The veterans of the 50s could handle this. They grew up wrestling levers. But by the 1980s, those masters were retiring. The tricks of the trade were leaving with them. In their place came a new generation raised on hydraulic machines. Smooth, forgiving, computer-aided. They couldn't do the tap dance. Running a 98 required independent rhythm for all four limbs. The new guys lacked the muscle memory. The result was jerky movements, massive shock loads, and accidents. The LS-98 didn't suffer fools. It punished incompetence with funerals. Suddenly, the machine was fighting a war on two fronts. It was too hard to learn for the new workers and too risky for the owners. Insurance premiums for friction rigs doubled, then tripled. The industry decided it couldn't afford the cost of speed anymore. Contractors stopped asking for the fastest machine on Earth and started asking for the safest. The era of the outlaw operator was over. But just as the industry turned its back on friction, a tsunami was forming across the ocean, and it wasn't coming to compete with the LS-98. It was coming to extinguish it. By the mid-1980s, the American job site changed. The rhythmic clanking of friction clutches and the scream of Detroit diesels started fading out. The yellow iron invasion had arrived. Caterpillar, Komatsu, and Hitachi flooded the market. For years, Link-Belt dismissed these hydraulic machines as toys or leakers. The brass in Cedar Rapids thought they understood fluid power because of their Speedomatic system, but they were dead wrong. They missed the difference between control and power. The LS-98 used low pressure, 300 psi, just to push a clutch. It was a servo. The new Caterpillar 245 used massive pressure, 4,000 psi, to drive the boom directly. It was a weapon. The difference came down to how the machine fought the dirt. The LS-98, like all cable shovels, relied on tensile force. You threw the bucket out and dragged it back. You were at the mercy of the soil. If the ground was frozen or the rock was hard, the bucket would just ride over the surface. You couldn't force it to cut. It also limited your reach. To get the bucket out further than the boom, the operator had to cast it, swinging the machine and releasing the brake at the exact moment to throw the heavy bucket outward like a fishing lure. It was an art form that took years to master. If you missed your timing, you smashed the cab or missed the cut. The new hydraulic rigs operated on compressive force. They had rigid booms and positive down pressure. An operator could plant the teeth and force them through frost and blast rock. A single hydraulic hoe could do the work of 3 cable shovels and didn't need a wizard to run it. But Link-Belt didn't see it coming. They were blinded by a disaster disguised as success. During the 70s, the LS-98 had a massive backlog. The waitlist for a new machine was 2 years long. It got so crazy that used LS-98s were selling at auction for 125% of the new price, just because you could have it today. FMC's spreadsheet managers looked at those numbers and saw victory. They thought the market loved the machine. In reality, the market was starving, and FMC was too slow to feed it. Instead of investing in the hydraulic future, they doubled down on the old cable design. By the time they woke up, it was too late. They tried to panic build their own hydraulic machines, the LS-3000 series, but they were Frankensteins. They were basically cable frames with pumps bolted on. They were trying to solve a hydraulic problem with a cable mindset. The geometry was all wrong. A true hydraulic excavator needs a center of gravity that shifts with the digging cycle. The LS-3000s were balanced like cranes, heavy in the rear, light in the front. They couldn't apply the necessary down pressure without tipping backward. They were heavy, slow, and expensive. The competition ate them alive. The market dismantled the LS-98 piece by piece. Digging lost to the hydraulic excavators that could rip rock. City work lost to urbanization. The LS-98's massive tail swing made it a dinosaur in a phone booth. When Sumitomo Heavy Industries came over from Japan to rescue the company, they brought cold, hard realism. They didn't see a legend. They saw a relic. The industry now demanded safety, computer controls, and air conditioning. The LS-98 offered none of that. In 1997, the line finally stopped. The last LS-98 rolled out, ending a 43-year run, one of the longest in heavy equipment history. It was the end of the friction age. The era where the operator was the engine was over. But the story didn't end in the scrapyard, because in the most hostile environment on Earth, the new perfect machines had a fatal weakness, a weakness that would force the industry to beg for the one thing they thought they had killed. You'd expect a machine designed in the Great Depression to be rusting in a museum by now, or melted down for razor blades. But if you go to the frozen hell of the Alaskan North slope today, or the blistering heat of the Texas oil fields, you'll see something strange. The Link-Belt LS-98 is still there. In fact, in the pipeline game, it's still the apex predator. This isn't nostalgia. Companies don't keep 60-year-old iron around for sentimental reasons. It survived because of a specific variant that solved a nightmare modern machines still can't touch. When the Trans-Alaska Pipeline started, contractors hit a wall. They needed heavy lifting capacity to move massive pipe sections, but they had to get the cranes into places where heavy haulers couldn't fit. The haul roads were narrow and the mud was deep. Link-Belt's answer was the LS-98 PL, the space saver. A standard 98 is 12 feet wide. That's a wide load. It needs permits and pilot cars. It's a headache. The space saver was a masterclass in packaging. The engineers in Cedar Rapids designed the crawler frames to retract. In under an hour, a crew could mechanically draw the tracks inward, shrinking the footprint from 12 feet down to a legal 8'4". You could slide an 80,000-pound crane onto a standard lowboy and drive it down the highway like it was a Toyota Camry. You could even drive it straight into the belly of a Lockheed Hercules aircraft and fly it into a valley that didn't have a road yet. But getting there was only half the battle. Keeping it running was the real trick. In the Arctic, the thermometer hits 60 below zero. At that temperature, physics changes. Modern hydraulic excavators are full of rubber O-rings and high-pressure hoses. In deep cold, rubber turns to glass. It shatters. The hydraulic fluid turns into jelly. A modern machine will blow a seal and bleed out in 10 minutes. The LS-98 doesn't care. It's built on mechanical linkages. Steel is steel. The heart of that resilience was the engine, the General Motors 471N, the legendary two-stroke Detroit diesel. These engines were simple, loud, and practically unkillable, but they were cold-blooded. If you shut one off at 60 below, you weren't getting it started again without a fight and a case of starting fluid, what the crews called the ether bunny. So the Oilers just didn't turn them off. They ran the engines 24 hours a day for weeks on end. The Detroit heartbeat kept the iron warm and the oil moving. But you couldn't just let them idle at low RPM or a Detroit would wet stack, loading the cylinders with unburned fuel and slobbering oil out of the exhaust stack. You had to run them at a high idle to keep the combustion temperatures up. So the camps were filled with the constant, high-pitched scream of two-stroke diesels running all night long. But there is a more subtle reason the pipeline boys refuse to let this machine die. It comes down to the tie-in. Joining two sections of heavy pipe requires finesse that borders on art. You have to lower a massive steel tube millimeters at a time while a welder is lying in the trench underneath it. Modern hydraulic valves are binary. They are open or closed. You move a joystick and the computer guesses how much fluid you want. It isolates you from the work. The Speedomatic system is different. Because the hydraulics are just pushing a mechanical clutch, the operator can feel the tension of the load through the brake pedal. It's a direct line of communication between the steel pipe and the human foot. For the specialized crews doing this work, that feedback is the difference between a perfect weld and a crushed worker. This unique capability has spawned a cult. There's a network of gurus keeping these dinosaurs alive, trading tribal knowledge on where to find friction linings and clutch springs. The only thing that might finally kill the LS-98 isn't the cold or the work, it's the government. The old Detroits are Tier 0 engines. They are illegal on many modern job sites. So to keep the legends legal, owners are ripping out the old two-strokes and repowering them with modern John Deere Tier 4 engines. They are building Frankensteins to keep the frame alive, because after 70 years, the industry still hasn't built a better tool for the job. The Link-Belt LS-98 was the summit. It was the absolute peak of the friction age, a time when the only limit on the machine was the man sitting in the seat. When that production line finally stopped in 1997, the trade changed forever. We traded the raw speed and the feel of the clutch for the safety of the microchip. We gained a lot of protection, sure, but we lost the connection. We lost the days when the machine was just an extension of your own nervous system. That is why this survivor remains a legend. If you ever pulled the levers on a 98, or if your knees still ache just thinking about one, sound off in the comments below. Thanks for watching. We'll see you on the next one.